let's start today's session. Before starting today's sessions, I just want to recap the things here. So as you know, this program is running for almost 3+ years, and 75+ sessions are already delivered, and the complete recording and everything is available on the YouTube channel. So you can go to offline and learn that. And every first Tuesday of the month, we are basically sharing innovative topics related to VLSI technologies. And on third Tuesday every month, we are sharing sessions related to the system engineering. As today is the third Tuesday, so we are here with a topic where we are going to define the system. And in 2024, our new theme is that we are going to deliver a hands-on session. What does it mean is, first we are going to share the information related to the topic, and then some of our experts, Wasim, make sure mute the guys who are not speaking. Wasim? Okay, fine. I think there are few guys who are not yet muted. Please mute everyone who all are not speaking. Perfect. So today's is the third Tuesday, so we are going to present how the system is going to be developed. And today's session is how we can create solutions for consumer market applications, which includes wearable devices, a lot of appliances, a lot of smart gadgets and all. And in the part one of today's session, the experts from NXP are going to share the information related to the embedded system design and development. And then in the part two of today's session, we are going to give you the hands-on session. So it's a very good approach where if you are keen to develop some embedded system design, then it will be a good overview of the system. Plus, we can support you if you are interested in developing certain things. With this, we are going to start today's session, and I want to welcome Salil Jain, who is our expert and principal system engineer. He is part of the SC team involved in different system design and development, enabling customers, and he is involved in a lot of stuff. Himanshu is also now visible, so he is going to sail through how the system design is going to be developed, what all considerations to be done, and finally he will showcase you how the MCU Xpresso is going to be running on a certain platform. So with this brief information, guys, welcome to this platform. And as you know, this is a Campus Connect platform, and a lot of students plus NXP employees plus it's not just from RV College. RV College is basically hosting this session, but students across India are attending online. So with this, all the best and thanks a lot for all your support. And this platform is over to you. You can please go ahead and start the session.
Thanks, Manish. Hi everyone. So today we are going to talk about Eclipse-based MCU Xpresso IDE. Before starting this session, let me give you basic about Eclipse-based IDEs. So there are multiple IDEs available in the market. Some are Eclipse-based, some are very lighter in size, and they are licensed. Means you have to purchase it. So if we'll talk about the strengths of this Eclipse-based ICs, then they are like highly customizable because in this you have plugins allowed where you can fine tune it. Then they are very mature and stable because it's running in multiple domains from various years. They are open source because it is free to use, free to modify, and anyone can contribute and update this IDE. Then it is able to work on multiple cross platforms like Windows, iOS, Linux machines, and also it supports multiple languages. Although there are some weaknesses as well, like they are very complex in use, and also they are very sometimes it takes time to open these IDs. But in terms of strengths, if we compare it, then it's far better because it's free and also they are very vast. Okay. So in this session, the agenda would be like this. First, I will give you a basic about ARM-based MCUs portfolio. Then we'll go through this introduction to i.MX RT1064. This is a crossover MCU, and the demos would be running on this board. That's why I will give you a basic about this hardware. Then there would be some slides on like getting started with MCU Xpresso and the configuration tools. Then there are some advanced debugging techniques which would be covered by Himanshu, and there would be a demo at the end. Okay, so if we'll talk about different types of ARM-based controllers, so as you can see in the name A, R, and M, so A is specifically for the vast applications where you need to run high or complex applications like based on voice, audio, graphics. Whereas if we'll talk about MCUs, so M stands for Cortex M core, which is mainly like LPC kinetics and S32K series, and they are like cost-effective solution, and they are mainly for low power-based applications. So what is this crossover? So a crossover MCU is a type of a controller which is designed to bridge the gap between this MCU and Cortex A-based cores. It's like microprocessor on one side are very high performing, but they demand more power, whereas MCUs are low cost, effective, and offer embedded solutions only. So crossover MCUs are like the combination of both, and they are best of both the worlds, you can say. So these kind of controllers have mainly high performance and high power consumption, advanced features. So i.MX RT is mainly based on Cortex M33 and Cortex M7 core, whereas i.MX ULP is mainly for the Cortex A core. So for in crossover, you can see like it's best of both the domains. If we'll talk about Cortex M core, so in Cortex M core, there are multiple cores like Cortex M0, M0 plus, M3, M4, M7. So in terms crossover MCUs, where we are covering i.MX RT is based on Cortex M7 core. So as I was mentioning in the previous slide, so in Cortex M core, there are multiple based, and you have to select the controller score as per your requirement. So in terms of requirements, the parameters would be like what kind of performance you are looking for, what should be the power consumption, how much cost you want to invest, then whether you want a security or not in your controller. Similarly, there are multiple features related to digital signal processing. Then there is a flexi floating point unit support, like whether it is a single digit or double digit. Then trust zone, if you want a security, then you have to implement trust zone as well. Then SIMD, single instruction multiple data for graphics. So on this basis, there are multiple cores available. Some are based on von Neumann architecture, whereas some are on Harvard architecture. So in that terms, we can define like there are multiple cores, and here we are covering Cortex M33 and Cortex M7 core, where we have a trust zone in Cortex M33, as well we have DSP as well as SIMD and all the features available in a Cortex M core. And you can see the performance is also increasing as you are changing the core from Cortex M0 to M7. Now I am going to explain you about i.MX RT controller. So if we'll talk about this controller, so there are this controller is mainly been built on 4 pillars. So the first one is the high performing real time processing. The core can operate up to 1 gigahertz. So it means that generally the cores on Cortex M7 which are available in the market are not up to that high much frequency. So this is 50% faster than the current existing M7 products. And also it has having a Cortex M33 core, which is running at 300 megahertz with trust zone feature. And also there is a 1 megabyte on chip static RAM. So it means that in terms of RAM, you don't need to add any external RAM. If we'll talk about high level of integration, so it is also provides a critical usability features from the MCU based product design spaces, while supporting product design that includes advanced multimedia for GUI and advanced human machine interface experience. And also it has a security like AES advanced encryption standard. And also there is a quad SPI feature like for copying the data directly from the memory. Also, there is a support for LCD and graphics. In terms of low BOM cost, there is a competitive pricing because it has a fully integrated DC-DC part inside the core itself. So no need to use additional components. Also, in terms of cost, it enables 2-layer and 4-layer PCB design. And as I mentioned that there is a 5 megabyte of on-chip SRAM, so there is no need to add any external RAM. So in that terms, you are saving the cost also. And the fourth pillar is easy to use because there are multiple IDs which are supported by this controller like MCU Xpresso, IR, and Kyle. Also, they are rapid and easy prototyping and developed with MCU Xpresso software and tools. Also, it is scalability to LPC kinetics and i.MX RT products. So in that term, you can say that i.MX RT series is very vast, and also from cost perspective, it is not that expensive, so that it can be easily used for the different applications. If we'll talk about the block diagram, so as you can see, like this is the Cortex M7 core of this controller. So this is the mainly the heart of this core. Then it has a 32 KB of instruction and data cache. Then, as I mentioned, it has a support for floating point unit, as well as there is a nested vector interrupt controller for managing the interrupts. Also, it supports thumb to instruction set, and there is a support for multimedia applications. Then there is an internal memory like 4 megabyte of flash. Then there is a static RAM as well as ROM available. From power management perspective, there is a DC to DC converter as well as LDO is available. Then from controlling part, as you can see, there is a JTAG, secure JTAG available for programming of the controller. Then there are multiple timers and watchdogs, flex PWMs and multiplexers are there. In terms of connectivity, you can see here like there are serial communication, there is a inter-integrated circuit, serial peripheral interface, flexible I/O, and then there are multiple transmission receiving ports. Then there is a CAN flexible data. Similarly, there is a support for USB. So all kind of features are like available in the market nowadays are inbuilt in this controller. And it's very vast controller because it's a crossover MCU, like it's a best of both domains. So in that terms, it is very vast controller. Now, let me jump to the MCU Xpresso, which is like a Eclipse-based IDE, and I am talking about this and the configuration tools of this particular IDE. So whenever any startup or any person want to start its development, then the ecosystem is a major thing, because when you want to develop something, there should be some ecosystem so that anyone who wants to develop any application, they have at least some base so that they can use that base and then easily develop that application on top of that base. So if we'll talk about that base, so NXP is enabling those by giving many tools and features so that anyone can easily adapt to this NXP's IDs and the controllers, and they can easily develop their application by using these tools. So as you can see here, like if we'll talk about core technologies, then there is a MCU Xpresso ID. Then there are different software examples available. Like if you want to select any controller, then you just need to select the SDK for that controller. And then there are very basic examples easily available for you, which you can run on the hardware, and then you can see how they are working. And on top of that, you can run your application. Then there are configuration tools. Suppose there is a controller and you want to configure that controller, like how many pins you want to use for any IO, then how do you want to configure any senior peripheral interface, how do you want to configure integrated circuit. So by using these configuration tools, you can assign the pins, you can assign the clock, and also you can generate the code also. And then there is a secure provisioning tool mainly for secured applications. So if you want a secure provisioning or bootloader part, then you can use this provisioning tool for that. Then regarding the software technologies, so there are multiple runtime software libraries and middleware is available, which is mainly enabling the customer to focus on different differentiation, and they can easily adapt them, and then they can run their application on top of that. And in terms of tools and technologies, there are multiple partner IDs which are supported by NXP's controller, and there are multiple debug probes. So debug probes are mainly for the debugging, like FreeMaster, Seger. So there are multiple debug probes which are available. Then you will see like there are multiple development boards are also available, where you can select your controller, and on that controller there should be a development board which you can select, and then you can run your application. So in that terms, this is a whole ecosystem which is available from NXP, and then you can use that ecosystem and develop your application. So as I was explaining in the previous slide, you can see here. So if you want to develop any application, then there is a cycle for that. So from starting, if you see, first you have to select the device. So when we know like what is the application on that requirement, we can just select like whether you want to go for Cortex A core, R core, or M core. Once you selected the core, and then you have to look into the requirements, like what kind of features you want, whether you want a DSP or not, whether you there is a requirement of floating point unit or not. On that basis, you can select your controller. Suppose if you want to develop any variable solution, then you have to look into like what is the power consumption, whether it is a low power device or not. On that basis, you have to select the device. Once you selected the device, then you have to evaluate and learn about the device. So for that, as you can see here, there are multiple evaluation kits which can be selected from this NXP website. And then based on your requirement, based on the device, you can select the evaluation board, and then you can evaluate and learn about that board by using the SDKs, by using those examples. So as in this cycle, you can see there is a free master, which is a debugging tool. Like if you want to run any example, you can debug that example by using this free master visualization tool. And then if you want to program that board, then you have to use this MCU Xpresso IDE. Although it also supports IR and Kyle, so it's up to you whether you want a free tool or you want a licensed one. So based on the requirement, you can select the ID. And also after evaluating and learning the board, if you want to configure your controller, then you can use this configuration tool where you can do the pin assignment, clock setting, and everything can be managed by this configuration tool. So, so if you'll see, like once you evaluate your device, then you created your application by using different tools, and then at the end you created the final product. So if we'll talk about the final product, so here you don't need to start from scratch. One reference solution is available. The applications, basic applications are available. You can run those application on these evaluation boards. Then you're on base of requirement, you can miniaturize this board into your requirement. You can create a final product, and once the trials are done, then you can go for the mass production. So here you can see like how NXP is enabling you in a mass production of your device by giving these reference solutions and reference designs. So here I am talking about MCU Xpresso IDE. So as you can see in this picture, this IDE is mainly based on ARM GCC and ARM GDB tools. So ARM GCC is mainly like GNU compiler collection for ARM architecture. And here there are multiple libraries supported by this GCC. So redlib is the library which is the optimized one and designed by NXP for mainly for the compact applications. Whereas if you want to go for vast or complex applications, then you can go for new lib as per your requirement. Then there is this GDB is the GNU debugger for ARM. So if you want to debug your application, which will be covered in the demo session. So during the debugging, you can use multiple options like CMSS, DAP, PE macro, Segro. So these are different tools mainly for the debugging, which helps you or which enables you for the debugging of your code. And on basis of those ARM, GCC, and GDB compiler, you can run your application. On top of that, there is a development perspective. So IDE is mainly here is the integrated development environment, which is mainly enabling you to edit, debug, and compile your code. So you are writing your code in C, but this IDE is compiling that code, creating that hex or binary file required by the controller, and also doing the debugging and also the checking about the linking and configuration. Everything is managed by this ID. So as you can see here, like there are multiple blocks here, like for RTOS, if you want, like there are tracing available, energy measurement, peripheral view if you want to see, if you want to manage your SDK, the software development chain, and also so everything is integrated in a single ID. Where you can do anything by using this configuration tool. So these are some screenshots from that ID. Like this is the main window where this project generally looks like. And when you do the debugging, then you can stop your code anywhere you want, and then you can see like what is the value of this variable here, whether it is jumping here or not. So suppose you developed one application, so this tool is enabling like if you the application is working fine or not, or whether it is stucking somewhere or there is a hard fault. So these kind of things you can be managed by compiling it through IDE. Also, if you want to flash your code in a controller, then you need this. You can also do the by a flasher, but this IDE also helps you to flash your code in a controller also. In terms of GitHub development, so NXP is also managing a GitHub repository. This is a link of this GitHub repository where you can check this URL and you can see the applications available here, and based on your requirement you can just download from GitHub, and then you can compile it and see like what are the features here and how you can use it for your application. Then this next slide is mainly covering about the software and tools. So this is the link where you can just check on your control on your laptop, and then you can see like there are multiple IDs, SDKs, and configuration tools available. And you can easily, there are website communities available. Like if you stuck somewhere, you can directly write in these communities and someone will respond and resolve your queries. Also, there are multiple blogs already available where you can check your issues and then see like whether any similar kind of issues are already there or not. On that basis, you can easily resolve your queries. So, okay, so now I am jumping to this advanced debugging techniques with MCU Xpresso IDE. So here I am mainly covering some basic points through this IDE, like how this IDE looks like and what kind of features you can manage by this IDE. As you can see here, let me show you this IDE also. So this is mainly the IDE where you can see like this in this IDE. There are this is the let me jump it to here. Okay. So as you can see here, so this is the ID. First, you have to. Okay, I think I have to change my screen. Just a minute. Yeah. So now I am showing you one ID. This is the main ID which I have opened. So when let me close this ID first so that I can show you from the starting now how it looks like. Uh, So whenever you open an ID, it generally asks for like a location where you want to save your projects. So first of all, you have to give a path like where you want to keep these workspaces. So as I have already created one path like workspace demo, you can give any name. So in the browser, as you can see here, so there are multiple workspaces created by me. So you can create any workspace directory where you want to keep those workspaces, and then you can launch. It may take some time to open, and once it's opened, then you have to open a workspace or you have to import your project there. You can also create your own project, but right now I will mainly focus on like if there is any example available, then how you can import that example. So it's just coming in a minute. Yeah, so it's open. So now it's starting the ID, and there should be one example already available. So first it will open by this welcome page. You have to just close this welcome page, and then there is a workspace view where you can see there is already a example available. But suppose if there is no example, then it should be blank. And then you have to either create a new CC project or you have to import an SDK example. Before importing this SDK example, there is an option of this SDK to install. So like if we'll go here, import SDK example. So as you can see here, there are multiple SDKs available, and you can select those SDKs as per the requirement. So first you have to download that SDK from the website directly, or there is an option in the ID itself for installing any SDK for that specific controller. So once you selected, then based on your requirement, suppose I am selecting right now this Freedom board, but later on we'll cover with i.MX RT board. So once you selected this any ID which you want to debug, then after selecting this ID, you have come with multiple examples here. So as you can see here, there are by default multiple examples. You can just start searching like what kind of example you are looking for. So suppose I'm just looking for a very basic example LED. So if you'll see here, like there is a LED blinky example is available where when I will run this code, the LEDs will blink. So when I am opening this example, so this example is already open. So this is the LED blink example. And as you can see here, there are multiple structures here for the drivers, for the COM ports, and also there is a specific C. So first of all, we have to look like which is the main file. So main file always is the one where you have main, like the void main part or the int main or any. So the main should be the one from where your would be a main C file. So as you can see here, so this is the main C file where you have some hash includes as you generally write in a code in C like hash include stdio.lib.h. So similarly, there are some hash includes for this specific controller. So here we are using SDK. So there should be some specific files related to that hardware we are using. That's why these are board.h file, the peripherals we want to use, the multiplexer we want to use. On that basis, we have hash includes. Then there are some macros which are defining some definitions, and then there may be some global or local variables and some functions, and then there should be a main. So as you can see here in a main, there is some code, and this code is mainly doing the LED blinking of that code. So if that code is written and you want to debug, so you have to just press this debug button, and once you press debug, then then the debugging of your code will start. So once you have pressed these buttons, it will compile this code, and then it will flash this code on a controller or your hardware. So this code has been programmed, and it will jump to main. Before jumping to main, it there is a reset vector also. Will not cover that part here, but yeah, it should be like it's coming to main. But before that, there are some other steps also. But in generic, it generally comes to main, where it stop here. So now this debug tool is able to debug this code, like which particular line you want to run. So if you will see here, like this is the particular button for resuming your application. If you want to pause that application, then you will press this. If you want to terminate your debugging, then you will press this button. So as you can see, as I'm hovering my mouse over that particular feature, it is showing like what is the purpose of that. So it's very means like initially it will take time, but you can easily learn like what is the purpose of a particular symbol here. So here is like if you want to step into any function. So like suppose if I did press this, so this code is running now continuously. And if I want to pause this, I have to press this. So now it stopped here because there is a while one, it is continuously going here. And if I want to reset my code, so I have put one debugger here, and now I am pressing the restart button, and then I am just again after restarting. So as you can see, it's restarted and comes to here. If I want to now see like step by step of this code, then I have to just press step next, a step over, and it is just running one by one, like what is the purpose of a particular line. So now if there is a variable here, if you want to see like what is the use of that variable, how it is working, you can easily do that part by doing this step into or step next. And also there are windows here, like for the global variables, there is a window where you can see the status of your global variables. And also here is the option of image where you can see uh, once you have to load this example here, and you can see like what is the memory usage here. And then if you want to see the memory contents of each particular variable or section, then you can easily check here. And then is a call graph as well, like where you can see like what are the functions here, how they are managing. And then here is this is the call stack, like how your code is running. So by using these particular windows, you can easily check like where your code is and how it is jumping, and then you can easily debug your application. So now I am handing over to Himanshu for the remaining section, like where he will explain you about the remaining part of this MCU Xpresso ID.
Thank you, Salil, for this great introduction. Let me just share my screen real quick. Yeah. So as Salil has already explained how to invoke a particular project, let's say. So this is for this, first of all, we need an SDK, right? So as we are able to see the board, right? You guys can able to see the board. So we are using this i.MX RT 1064 EVK. EVK stands for evaluation, and this is basically our controller. And then we have this Arduino compatible connectors out there. There is this 5-volt DC jack for the external power supply. We have this USB OTG for another power supply. And currently, as we have already set the power supply via this USB debug USB using these boot settings, using these power supply settings available here. We also have this boot setting right here in this board. This is for because you already have SD card, right? We can boot from SD card or from the internal boot. So I've set it on internal boot for the time being. And there are other peripherals. For example, we have Ethernet. And then now let's jump on to this MCU Xpresso IDE. For this particular board, i.MX RT or any other board, if you want to explore, right, we have this button. For once you click this one, let's say our device is i.MX RT, as I have already downloaded the this SDK for this one. But if you haven't, it will showcase highlighted, let's say for this one. And if you want to install, we just need to press install and it will fetch an SDK for this particular device. That was a restore button. And then after once we install this particular SDK, right, we can import any SDK example, right? So for example, this we need to select this particular device, click next. So there are multiple examples available for this board. Let's say for the demo apps, we have Hello World, right? It will just print a Hello World message for you if it works fine. So I'm just currently importing into my workspace. So as you can see, I was having this project already imported. I just imported this project named Hello World. And if I want to basically build it, right? So there is this build button in this quick start panel, or you also have this hammer button. If I click this one, I'm able to build this particular project. If there is no error, it will showcase that build finished with 0 errors, 0 warnings. Now we are good to go ahead and we can basically download the code into our hardware. For that, there is this button. We have debug, right? If I press this one, it will download this. Let me start with Blinky only. Okay, let me debug this one for you. So this will download this code, Blinky code, into our evaluation board. As you can see on the screen, it has already debugged, and now we are in the live debugging session. So as Salil has already explained, there is these buttons. Now you're familiar with this. So let me jump onto the debugging techniques, right? So we have these global variables, right? We want to debug some things. So for example, in this application, you have this pane. In this pane, it is already showing global variables. Well, let's say there are others, and you want to have more global variables to debug the values out there, right? We can choose and add in here. So let's say I'm just currently using this stick counter. This is just an application in the Blinky. It will increment this stick counter. So if I play it here, right? And there is this button, you have to enable this, right? So every 1 second, this is 1000 millisecond, it will be incrementing the value, right? And we can see it live. In the registers view is already there. So if you see this pane in the left, we have all these registers. All these registers, and then you have these cycles, how many cycles I've spent. If you create 2 breakpoints, let's say if I take this breakpoint and then again I put another breakpoint, so it will again show a delta between this breakpoint, line number 62 to line number 66. It will also show the cycle spent in between those breakpoints. Then we have this peripherals there, because those were not the only registers we have. We have a lot of peripherals, and if you want to see the peripherals for what the registers hold, we can go up here and we can select a particular peripheral. We can see that. Faults, let me cover that up real quick. So let's say there are multiple kind of faults can arise, right? For example, bus fault, hard fault. A bus fault can also eventually leads to a hard fault. Let's say, for example, there is a register which on which you cannot have write access, and you have basically logged. So you have, as per the RM, you have to unlock that register before writing over it. So if you're trying to write that kind of a register, it will lead to a bus fault and eventually a hard fault, and which you can see it here. Currently, as our application works fine, we are not able to see any faults. Heap and stack views, right? So this kind of a view we can see right here, this window, right? So currently, this is kind of a heap and stack usage for this application, we can see. And okay, these kind of settings. Okay, so there is, if you go to the Project Explorer, select the particular project. If you do a right click and go for properties, or just simply press Alt Enter, you'll end up seeing this properties page. Right. It will showcase you a lot of things. Let's say in MCU settings, we can see what kind of regions. We define the flash region starting from this location, the particular size. Let's say if you want to add or split this particular flash, we have these options right here. You can add a flash, you can add a RAM region, which is currently not already specified here. Or if you want to split this particular flash, if the needs persist, we can do that, right? So about the breakpoints, let's say if I want to halt an execution, as Salil already told you, we start from main in normal terms, and then if I press a breakpoint here and let me restart the application in the debugging session. Now we again start from main. So we are currently at line number 62, and if I press resume now, it starts the execution continuously. But as I already created a breakpoint at line number 66, the execution stops at line number 66, and then now it's my choice if I press continue. If I want to debug something, as it's a function, right? I can step into and it will take me inside that function. If I want to go step by step, line by line inside this function, I can go, or I simply can press this step return, which will take me out of this function, basically, in which currently I am. And as you can see, we just reached on line number 68 after 66 has ended. And if I simply resume the session, it hits the another breakpoint. And how many breakpoints we already have? We can see it here in the breakpoint session. So we already introduced this 2 breakpoints on line number 54 and 66. So if you want to remove, let's say, all the breakpoints, so we have, or skip all the breakpoints, we have an option here, because in a complex ecosystem, you're not only going to play with the 1 or 2 breakpoints, right? Assembly. Okay, so disassembly also we have here. We can see the disassembly. If you click this instruction button here we can see the disassembly of the same program on the particular line we have. If we want to debug it here, we can also mark a breakpoint on this line. all you need to press, you have to tap 2 times, okay, and the symbol of the breakpoint appears, and we can also debug in the disassembly. This one, right? So watch points are nothing but the breakpoints on the data reader, right? So basically there are 2 ways. Either you have a watch point in the memory itself or on that particular variable. So let's say we have this stick counter, right? Here, right? So if I go toggle watch point, I can apply simply, and you can see we have this watch point here. And we can also put the conditions in the watch point, right? So for example, let me put it here, condition, right? So let me ignore 10 times. My condition is that we have this 900 as the value of that. Okay, GC stick as greater than 100, right? So we have to put, right? And I just want to ignore for the 5 count or 10 count, it doesn't matter, right? So if I apply and close, now if we see the variable, this value is currently 0, right? Let me restart this one. So only this only works for the first time, right? If the watch point, I have set the watch point and now the condition is marked true and that condition has holds true for the first time, the second time it won't work. So right now as the value is 0 and our condition was to, if this stick counter goes greater than 100, you have to ignore that 5 times, right? If that holds true, the other thing is you don't have that condition valid. You again have to go for uh, this toggle watch point, and you again have to make another condition out there. So now my condition could be something different. Let's say now this time it is greater than 50. I have to ignore 10 times this time, something like that. Okay. And currently we are at so it starts from 900. So here we have watch points from memory view. The other one is watch point from memory. So we can also view it in the memory, right? So if we double click it, we can select it here, and here we can add a watch point. So here it says for the range of 4 bytes, right? So the 32-bit, we are applying this. We can make a condition, and that's all. So here we can see, let's say, for example, if I press the start button, we can see this value as this is basically a breakpoint and basically stops execution for you after a particular value hits. And if the value changes, it will showcase in the memory directly. So we can basically, it's a watch window, but in the memory you have to see the values getting changed. Let's see, it's DC now, DB, right, DA. Now in the function return, this is for a different kind of debugging. Let's say you're not returning a variable here, right? It's not a global variable you are returning, and you are going to see it in the global variable window. for that, what we can do is we can halt the execution at the return statement itself. Let's say you make a breakpoint at the return one, right? Or in the end of the function return, and then you can have that value observed. Let's say for here, I can have this breakpoint on line number 54, and if I start the execution continuously, it hits the line number 54, and I can observe what the value of return statement is. Also, if this is a, let's say if this is a big function, right? And let's say 1000 more lines. So what will happen is on the line number 51 or 53, let's say, you just have to press this step return, and what it will do, if you're inside a function while debugging, it will try to get out of line number 56. But as on the line number 55, we already has this breakpoint, so it will hit that line number 55, and on that basis you can also find out what the value we are returning. And this value, because this value is now changing, right? It is depending on the I, and I don't know how many times I would have changed between this function. So the last value I can observe is on the line number 59 due to that breakpoint. So that's the same thing. And then we have this step return value. Same thing. So for the HMI demo, as we are currently, as I've already shown you this Blinky example, right? That was a very basic example we have. We can also have this another example, right? If we want to invoke, you again go to the quick start. There is an option import SDK examples, right? If I invoke another example, let's say for the HMI, we have this library, LVGL, Light and Versatile Graphics Library. It's an open source, free to use, and widely available. So we're using this one. Let's say this particular, not all, but this particular example. So usually it includes this library. It will take time to build and everything. I have another workspace already opened. I can showcase that one. This one. So once you have that imported, right? That example imported, it will look like this. Again, as Salil already told you, there is a main function. For any project you imported any example, there is a source folder inside the project where you can have this main file available. So for this one, and this is on the name of the example code itself. So example code says lvgl demo widgets. You have lvgl demo widgets.c, and here lies our main function. And once I press the debug button, right? Let me showcase how the demo will look like. I have just tweaked this demo a little while, you can see on camera, right? And let's just, so this is basically an application showcasing that if you want to shop something, right? We have this. And this is very seamless. So for this demo, I'm currently using this MCU Xpresso IDE, the SDK I told you that this is the version 2.14. Hardware requirement is we are using this 1064 EVK board. Host machine, I'm using Windows currently. LCD board, so this is the LCD interface. This is our touch screen, and we are using. So for this demo, you can also see we have this analytics over there working seamlessly. We can also change colors, by the way. Notice. And this is it. So it's very easy. Anytime you just have this whole SDK for any device from the NXP, get an SDK and just import an example. If you really want to have your own example set up from scratch, you can go to the devices RM, go to the data sheet, find out the connections, boot sources, everything connected, and then easily works this workspace. I mean, this is really easy to switch workspace. If you have multiple workspace, you can just click on it. And even in the single, let's say this whole workspace, consider this whole workspace for me for this particular device I'm going to use, right? For 1064, I just have 2 projects in front of you. We can also link these projects, by the way. But yeah, for these for this example, we already have 3 example projects. You can create more and under the same roof as workspace. Thank you.